related with IDT, and today we're going to do the first of a little short series of videos on PCI Express clocking architectures. The first video today we're going to define what the architectures are, and then in future videos we'll discuss the impact that those timing architectures have on the clocking requirements for the system. But let's first define the architectures themselves, and there's really only two basic ones. There's what's called the common clock architecture, which was the original architecture for which PCI Express was defined. And common clock, as you would imply, means there's one clock that services, for instance, the CPU over here, and that same clock also services, let's say, I/O or storage. And this is great. It's the original architecture for which PCI Express was defined. However, it does have a couple of limitations. For instance, this I/O and storage might be in another box separate from the CPU, which means in a common clock architecture you have to still provide a copy of this clock over to the other box, which might be through a long cable, in which case you now find yourself running clocks very long distances, and that can be a problem sometimes. So there's another architecture that's defined, and it's called separate clocking. And as the name implies, the CPU has a clock, and in this case the I/O or storage has its own clock, and they talk back and forth via PCI Express without sending the clocks back and forth. This is a relatively new architecture called separate clocking, and it hasn't been fully fleshed out through the PCI SIG yet, but the work is underway. We'll talk next time about the impact of the architectures on the timing solutions for them, and that's it for today. Thanks.